The first step of our dust simulation is to create a density source. Now I'm going to start by taking the same source that we set up for the week 6 building debris. So if you go back to that setup and just copy this entire source geometry portion, this will give us a good starting point. So we'll copy that and go back to our week 8 dust setup and paste that in here. Now, as in the building debris setup, we're using this scatter area that we set up for the rebar as our source geometry, and we can leave a lot of this the same, our attribute cleanup and packing that. Although in this case, I might want the small pieces of RBDs to emit some dust as well. It's fine for these small pieces to not emit debris, which is why we got rid of that for the debris setup. But in the dust, I'll start by allowing even the little ones to create some dust trails as well. Now the rest of this we can leave the same. We're adding this temp normal so that we can calculate the velocity and the angular velocity on all of those moving packed pieces. For this dust setup, I'm going to bypass this delete slow moving option here, because even if a piece is moving pretty slowly, it might be nice to see some dust forming along those cracks. So we can just bypass that. And moving on to the age and density wrangle, we're going to emit for a bit longer than we did with the debris. For the debris, we only emitted for 10 frames, but we often want these dust trails to linger a little bit longer. So I'm going to turn the age limit up from 10 to 30. So this will emit for 30 frames. And in this wrangle, we've already set this up to remove the pieces that are not currently emitting. So if we scrub through here, you can see we're only isolating the pieces that are emitting some density. Now currently, this density has a linear fall off from 1 to 0, but if you want some more control over the curve of the fall off, we can add a ramp for that. If you add in this line of vex and hit the button there, that will create this density ramp channel that we can use to control the curve of that fall off. And just for convenience, I'm going to reorder this and put it at the top of our wrangle UI. Now to tweak the density fall off, we can expand this ramp here to make it a little bit easier to see and control. And instead of fading down to a density of 0, I'm going to make that minimum value of density of 0.1. And then I'll set the interpolation to monotone cubic so that we have a slower fall off from those more dense values down to these lower values. The difference is probably pretty subtle, but that's what I went with for my version of the shot. And if you'd like, you can also vary the density differently based on the different sections of our building geometry. If we add this extra bit of vex after that density remap, this will check to see if our currently processed piece is part of the exterior of the building, and if so, then multiply that density times 2. In this shot, I really wanted to see some nice dense clouds of dust forming along the exterior surface, along those crack lines, which is why I'm multiplying this up a bit for those exterior pieces. Now after we've tweaked that density, we can unpack the geometry, making sure to transfer the velocity and density data, which is what we had already set up from that week 6 debris. And now we can scatter some source points. Now, unlike the building debris, we're not going to use the density option to control how many source points we're scattering. We're just going to use that density later for the actual density of the volume that's created based on these source points. So we don't have to worry about that density yet, but we are going to turn off the force total count and use this density scale parameter to control the density of those scattered points. In my case, I'm using 100. So we have these fairly dense point clouds scattered onto the interior faces of our emitting geometry. And now we have to be a bit careful when we generate our volume sources, because when we have moving geometry that we're sourcing from, it's easy for our density emission to look stamped. So if we take this piece, for example, here, if this is flying in this general direction so that on the previous frame it was perhaps here, and then on the frame before that it was maybe here. If we just scatter some density based on the current position at every frame, then we'll see some density here, and here, and here. But once we source that into our simulation, you'll see that stamped in these spots without filling in the area in between. And that's going to look pretty bad. We definitely want to have these nice, seamless density trails between the frames and the motion of the pieces. Now, because we have this velocity data on all of our points, we can just use that to extrapolate the point positions backwards to fill in those gaps between the frames. And we're going to create some polylines between the current points and those backwards extrapolated points. So we'll need an ID attribute on these to match the source to the endpoint. So let's add in a point wrangle after the scatter and connect the scatter to that. And this bit of vex will set an ID attribute equal to the current point number, and it's also setting a float end attribute equal to 0. Now to extrapolate those positions, let's create another point wrangle and connect our ID and end wrangle to that, and then we can use this bit of vex to extrapolate those points backwards. Now at the moment, this extrapolate back wrangle isn't doing anything because I'm using this custom channel extrapolation frames, and we have to hit our little button to create that missing channel. As usual, I'll bump that up to the top, and I'm going to set the extrapolation frames to 1.5. Extrapolating a little bit beyond one frame seems like it may help us to create these nice solid dust trails. So now that we have the current position and the extrapolated position, we can merge those together, and then we can create some polylines between those two positions. So for that, you can use an add sop, go to the polygons tab, and then select the by group tab, and then under add you can select the by attribute option. And then here we'll give it the ID for the attribute name, and that tells it which points to match up based on which attribute. So now we have some nicely connected polylines between the current position and the extrapolation back. And right now this is giving us perfectly straight lines between those two positions, and we might want to break this up a bit with some noise. So to add some extra detail, let's add in a resample sop, and in that length I'll set it to 0.05, and that will create extra points along these lines with that maximum length there. And now to break up those linear lines a little bit, I'll use a point jitter, and this will be a bit too extreme from the start, so I'll turn that down to 0.1 just to soften that up a little bit. And since we're going to be sampling these points into a density volume source, we want to keep a consistent distance between all of those points. So I'm going to resample this again. We can just use the same distance setting, so I'll copy that resample and add it after the point jitter. And this will help us to keep a consistent point density for when we create our volume source. Now, one little problem that we're running into here is that the ends of these lines might no longer connect properly to our source geometry. So if we template our source geometry, you can see a lot of these lines aren't touching anymore, and that could look a little bit weird when you source dust from this. So in order to remove that offset, we can blend down the amount of deformation based on this end attribute that we set up. And in order to blend that out, we're going to add some rest data before we start deforming this. So right before the resample, let's add in a rest position sop. And then after our detail is added, and after that final resample, we'll add in a point wrangle to blend this down. In that point wrangle, we can just use the lerp function to blend between the rest position of these lines and that jittered position. And since we created that end attribute with a 0 at the start point and 1 at the end of the extrapolation, we can use that for the blending bias between the rest and the distorted position to give us this nice fall off that you see here. So now we have these pretty nice source trails, and we can convert this into a volume, But in order to optimize our volume sourcing, we may want to remove the pieces that aren't in the camera view, as we've done with many other setups so far in the class. So as usual, we'll create our volume from the camera and we'll make it much taller in the Y direction. Let me turn off the lights in the scene so you can see that a bit better. And this Y padding on that camera is pretty important because we want that dust to be able to fall down from out of frame if it's generated above that camera frustum. So let's take our lines that we're using for our source, and then we're grouping based on that camera frustum and deleting everything that we don't need. Now to create our density source volume from these optimized lines, we can use the volume rasterize attributes SOP. Now in the attributes parameter, you can specify any of the attributes on your incoming geometry that you want to create a volume for. And it's very common for people to create both a density and a velocity from the same source. Sometimes I'll do that sort of thing, but I often like to build the velocity volumes in a totally separate pass, so I have some separate control over how that's created. So I'm going to skip creating the velocity field here, and we're just going to create the density. So you can type that in to the attributes parameter. And for the voxel size, I'll set this a bit lower to 0.06. Now this density volume is looking far too big and splotchy because our particle scale is too big. So if you turn that particle scale down to 0.1, you can see we have these nice, fine, and detailed density trails. However, these density trails are still fairly solid lines, so we can use some noise to break this up a bit. To add that noise, we'll use an attribute noise SOP, and we'll set the attribute name to density, and we'll set the mode to multiplicative. Now since density is a single float value, we can set the signature to 1D, and we'll turn on the remap option to set our multiplication range. We can set the minimum to 0.3, so we get 1/3 of the density at the darker parts of the noise, and we'll set that maximum to 1.2. I'm also going to turn on the animated option to vary this noise frame to frame, and I'll also set this element size to 0.5 instead of 1 for a smaller scale detail. So now if I bypass this attribute noise on and off, you can see that's adding a bit of breakup to those otherwise solid density trails. Now at this point, we can step through and see how long it takes to calculate this density source per frame. And however long this takes, this time is going to be added to your per frame simulation time if it needs to calculate this on the fly. So you could try caching this density source out to disk and comparing the time that it takes to load up that volume and see if that's much of a time savings. For now, I'm just going to wire this directly into the simulation, but it's definitely something to consider to potentially optimize your overall sim time. Now, as usual, in order to send this to the sim, we're going to add a null so that we can reference this in the DOPNet. I'll call this source density, and I often like to add a multiplier in SOPs as well so that I can vary this up and down easily. So to add that, I'll create a volume wrangle, and I'll drop this in just before our source density null. I'll call this density multiplier, and then I'll use this bit of vex to create a density multiplier channel. I'll hit that little button to create that missing parameter, bump that up to the top, and I'll try a multiplier value of 3. You can also add this multiplier within the DOPNet itself, but sometimes it's more convenient to have this in SOPs, and you can use a combination of SOP multipliers and the volume source multipliers in the DOPNet that we'll be looking at next. And one final note about this density multiplication is that if you do decide to cache this volume source to disk before the sim, I would make sure to keep this density multiplier after the cache so that you don't need to recache it just to change this multiplier value.